5 Intel session. We will be covering OpenDaylight enablement of provisioning of NSH, so Network Services Header, based service function chaining in a Gi-LAN use case. Now, if you say that really fast, I'll be impressed. This is the agenda we'll be following. We will take questions and comments at the end. So the use case that we wanted to go over is showcasing OpenDaylight provisioning network services headers in service function chaining using F5 virtual network functions. The goal was to integrate the disparate systems and components without looking at performance. Based on public available open source technologies and F5 commercial VNFs. The solution used OpenDaylight controller that is publicly available. At the time we implemented the lab, which was Lithium SR1. Noting there are other OpenDaylight versions that are now available, but we kept to the baseline we started when we started the project. We wanted to showcase VNFs that are typically in a Gi-LAN. We come from a telco background, and that was one of the places that we saw NSH and service function chaining being a key element in the network. So Gi-LAN, for some of you that aren't aware of it, it's basically the mobile service provider packet data network between the packet gateway and the external service provider network. The VNFs that we did put into this solution are ones that are typical in that space. There are also other areas where VNFs are applicable both in enterprise networks and service provider networks that can provide technology advantages and applications to different use cases that you might run across. The target for this, the target deliverables for this was basically to upstream fixes and patches and provide feedback and learning to the ODL community. For more information on NSH and Gi-LAN, please consult the document here below, the reference document. F5 has a broad range of VNFs or virtual appliances that can be used in software-defined data centers. The F5 VNFs are part of the Big IP Virtual Edition product line and have applicability to both network infrastructure in enterprises and service providers. The 3 highlighted VNFs here are the ones used in the demo, which Tarek will be going over. For information on the other VNFs, please consult the reference document below. And that, I'll turn it over to Tarek.
Thank you, Randy. Hi, everybody. My name is Tarek Radi. I'm a comm service provider and technical program manager at Intel. And today I'll be walking through the demo topology and showing you a quick demo of the solution that my colleague Randy from F5 here presented. Imagine that you have an evolved packet core front end. And behind that, you have a Gi-LAN network with a service function classifier, a firewall, an URL filter, and a bandwidth control. All 4 are managed by ODL. After that, you have an external packet data network behind which there's a web server that would like to reach out today. And for the sake of this demo, all service function classification is done based on source IP address. Of course, you can do it in different methods as well. So we have 3 main scenarios. The first scenario here is assuming you have an APN number 1, with a pool of IP addresses. This any caller coming in with that APN will be assigned one of those IP addresses in that pool, and based on the classification for this scenario, it will directly go to the web server. As for APN2, it has a different pool of IPs, and the classification there takes it through the red path, in which it goes through the firewall. And after that, it goes out to the web server if it passes the firewall rules. The third scenario here is a bit more complicated. The IP pools there get classified to go through a different chain. They go to the firewall, to the URL filter, and finally to the bandwidth control before they go out to the web server. So of course, we talked about being dynamic. You can dynamically assign different IP pools to different chains. So we'll show you that association in the demo. I would like to step a bit now into the software and hardware stack that was used for this demo that we started off in early Q1 of 2016. We have a 4-server setup. They're all based on Haswell processors, 2 of which are Wildcat passes. The other 2 are Dell PowerEdge R730s. They're all running Niantic 10 gigabit NICs, and this is the infrastructure stack, if you will, on these servers. Notice that server number 2 is our controller, and it has the ODL Lithium, while server number 4 has OVS DBDK, compared to server 1 and 3 and 2 having only OVS. So the only place where we have OVS DBDK in this topology is on server 4, and it will be apparent why this is the case later. On server number 1, we have our virtual machines. We have 3 user machines, VM1, 2, and 3, as well as a web server. Each one of these virtual machines will have a different path, as we showed in the earlier slide. We also have the F5 commercial VNFs. So on server number 3, we have the classifier, and server number 4, we have the bandwidth control, the URL filter, and the firewall. Note that these are all using the big IP version 12.10, and we were closely engaged with F5. We had to enable some functionality. There's a hotfix on top of that as well. And let's double-click on that and go deeper a bit and see how does the topology line up in this demo. Again, we have our 4 servers. We have a public and management network that's a 1 gigabit connection on this interface. I want to call out that on server 3, there's a floating IP. That's reserved for the classifier, while on server 4, you have 3 floating IPs, and those are reserved for the F5 VNFs there. So other than the management and public network up there, we also have an internal switch, again, a 1 gigabit connection with a different interface. And on top of those, you have your open vSwitch bridges on server 1 and server 3, while on server 4, it's an OVS DBDK enabled switch. And please note, SFF here is a service function forwarder, which forwards the data through the different nodes in a path. We have ODL residing on server 2, and we have the 3 user VMs on server 1, as well as the web server. I want to call out that the user VMs are on a different VLAN than the web server. You can see here VLAN tag is 409, I can read from there, 4094 versus the web server being 4093. We have the classifier in server 3, and we have the 3 NSH-enabled VNFs from F5 on server 4. So let's discuss quickly the the service function forwarder, the chains, and the paths that we have here. So we have a service function forwarder node in ODL devised as such. It has these 3 components connected to it. We also have 2 service function chains. The first chain is just the firewall. The second chain goes through, like I said, firewall, URL filter, and bandwidth control. And from these chains, we created these paths. Notice that we deployed or rendered the paths to be symmetric. So you get 2 paths per chain, and that's why you have one in one direction, the other one in reverse. So for example, it's clear here, firewall, URL filter, bandwidth control, and then when the data goes to the web server and back, it goes through bandwidth control, URL filter, and then firewall. So it's a reverse path on the way back. Let's just take a quick overview back to this slide and see how data from VM2 would go through this path. First, it goes through the OVS bridge on server 1, where it gets routed over to the classifier. Notice that the user here is going to be using the IP of the virtual server pool defined in the F5 classifier, which currently has only one member, which is a web server on server 1. So the classifier receives a request. It encapsulates that request and sends it over to the service function forwarder on server 4. After it does that, it looks up its OpenFlow tables and the rules there and says, OK, on ingress, I need to send this packet over to the firewall. And it sends it to the firewall. The firewall does its job. It returns back. Service function forwarder, of course, if a firewall decrements the NSH index, and now the SFF looks and says, OK, with this new index, what's my next step? It determines that based on this path, it needs to go back out. It's done its job. It sends a response back to the classifier, which encapsulates that packet and sends it off to on VLAN tag 4093 over to server 1's OVS, back to the web server. Notice that this, sorry? No, we'll show you that the classifier, there's a UI in which we specify, in a way you can say it's not really hard-coded because we're not editing the code there. We have a rule, and in there I'll show you in the demo where we specify the source IP and the path. Good question, though. Notice that this is only going from the user VM to the web server. Then it has to go back in reverse path. So these are the demo steps. I won't talk you through them, but I'll actually show it to you right away. So, and by the way, I have this demo. I'll be happy to show it to you downstairs at the Intel booth. So here's our ODL interface. I'll do a quick walkthrough first. We have the 3 service functions you can see. We've created the service function forwarder. When we edited the forwarder, inside we have the dictionary that specifies the filter, the firewall, and the bandwidth control. And as a result, you see the nodes over here, the service function forwarder node with 3 VNFs underneath it. When you look at the chains, here are the 2 chains we talked about. You click there, deploy this chain, and after you do that, it appears as a path. And you notice that symmetrical path is clicked. You click on render the path. The paths get rendered. You have them in this panel, and I'm sorting here by ID. You can see the 4 paths, and if we go back to our slides, if you remember, it just looks like it. And notice that each path has an ID, and this is where answer to your question. This is right now the classifier. In the classifier, we have a data group list, which is called client DG. And there you have an IP mapping to the path, saying if the source IP is 102, use path 43. If the source IP is 103, use path 45. And by the way, this data group list is used in conjunction with an iRule, which F5 has coded over here. And if you go down over here, we're showing you the code snippet. Now, if we move forward to the firewall has a bunch of active rules. Here's the rules that we've enabled. Notice SSH shows an action of accept. We'll be editing that as we go. And the URL filter has a rule that says, I'm going to reject all JPEGs. So again, you can dynamically change that in real time because you can specify whatever data group list you want to use. Here, I'm calling it the URL block list. It specifies block all JPEGs, and then there's an iRule with logic that uses that data group list. Here's the iRule, and it uses the URL block list. Okay, going to the URL filter. Moving over to the bandwidth control, we have here a shaper. You can see right now I reset the shaper so that it shows zeros on the right here, and I set it to automatically refresh every 10 seconds, so this page will refresh, showing you that right now the shaper is seeing no traffic come through. Now let's open up SSH portals to these 3 VNFs on the top here. This is the firewall. This is URL filter. This is URL blocker, and this is here. This window here is showing the service function forwarder rules. I'm logging on SSH here to the server 4. I'm dumping the OpenFlow rules. Here's the rules in there, and excuse the quality here, but of the display, it shows the path IDs 44, 45, 46. So it has the ingress and egress rules here. I'm going to run TCP dump on each of these 3 F5 VNFs on server number 4. And we're going to have that active in the background as we log on to VM number 1 and start running some traffic. So think of this as our control data set. VM1 does not go through any of the VNFs. The classifier sees it, doesn't find any rules for it. So all traffic, JPEG, video, goes through the F5 firewall. URL filter and bandwidth control do not show any activity on top there as I traverse. And I also do some SSH as well, because later in the demo we'll show you SSH, a scenario where it gets blocked and stuff. So right now, VM1, nothing gets impacted, SSH, video, and image. Let's log on to VM number 2. And VM number 2, remember, it goes only through the firewall. So when I load up the web page, you can see that the firewall SSH showed traffic. And I'm going to run some video as well. And notice, again, only the firewall gets traffic. Nothing happens in the other 2 VNFs. I'm going to log in here to VM3. VM3, if you remember, goes through the chain with all 3. So right now you saw all 3 VNFs get impacted. And if you remember, the rule was to deny JPEG. So if I click on JPEG here, after a while it will show that connection was timed out, because the rule was to block any JPEG traffic. And there you go, connection has timed out because the rule was satisfied. And if I load up the video, though, remember that goes through the 3rd path, which goes all the way. So you can see the action happening on all 3 VNFs. And you can see that the traffic is going slower on VM3 compared to VM2, because VM2 does not go through the bandwidth control, does not go through the shaper, while this one does. So I'm going to reload the video on VM2 here, get it to start from the beginning, while this one still resumes. And I'm going to show you here, if we log on to the URL filter, the F5 F5 bandwidth control, and we look at the shaper, you notice that it's already gathering metrics here, and according to the policy that we set. And notice that it is slower. VM2 does not go through the shaper, so it already caught up and is actually ahead of VM3. So now let's reset the 3 VNFs and take a look at SSH scenario. If you remember, VM1 had no problem and goes through. Let's go with the VM2 for now. VM2 goes through the firewall, as we remember, and we had a rule in there for SSH. We're going to SSH to the web server. You see the traffic going through the firewall. I'm going to log in through the password over here. I'm able to log on, no problems. So I'm going to close that connection and go back to the firewall here and edit the SSH rule such that it does a rejection. And when I do a rejection, I rerun the same scenario from VM2, and I will take a look at that and see that the traffic should be denied. Traffic is denied, or refused, if you will. And if I go back to the F5 firewall and do an accept, then I rerun that scenario, and it allows it through. So you can see dynamic enabling of different services of quality for users based on their classification. And now I'll hand it over to Kevin, my colleague from Intel, to talk about key learnings and call to action.
Thanks, Tarek. Is this on? You guys hear me? was probably the quickest video demo I've ever seen. A lot of words put into 5 minutes. So I'll kind of try to summarize what we did, what we learned, and the next steps are. So these are some of the issues that we ran into and resolved with the F5 VNFs. Randy, you want to just mention those real quick?
Yeah, so we ran into some issues with our code base. It was our first release of the NSH support. So we fixed those in the hotfix 19, which is available for F5 support. We also, as designed, we implemented some of the functionality in iRules, which those are the second 2 items. And we're actively looking at item 3 and how to find where that is in our system.
So here are some issues we ran into with ODL. We're using the opening release as Tarek went through earlier. Most of these issues are not found in Boron, the most recent release. But as we described in the beginning, the intent of this original engagement was to take publicly available code, ODL, OBS, OpenStack, what have you, see what we stick together, see where the gaps were. So you can see that item number 5 there, that issue is no longer seen in Boron. And item 6 there, when we UTDK enable OBS, we needed to manually add a flow to push up to the VNFs. So we did a workaround to create separate overlay and underlay bridges. There is a patch under development to add that Boron SR1. So just keep your eyes out for that one. Some infrastructure issues, so these are non-ODL, but from a solution standpoint, integration, these are some issues we ran into with NSH. The NSH header in OBS 2.4.9 was incompatible with the latest IETF draft. So we created some NSH patches that are available at that link from GitHub, and they'll be upstream to Gi-LAN OBS here shortly. Ideally. Some other issues that remain unresolved. So the first one there on the left, the VLANs with OBS TPK. VLANs cannot be enabled with NSH-aware OBS TPK. And as Tarek went through, there were some different settings we had on the server. Some were just called vanilla OBS, and some were OBS TPK. So we used OBS TPK on servers where VLANs were needed. Again, this is no longer an issue for us, so we encourage you to try it out. Next one there, OBS 2.4.9 didn't support NSH and VXLAN DPE. So we used DPK-enabled OBS that supported NSH patch. And we switched to the different OBS versus OBS DPK on the servers where we need to use VXLAN DPE. The third one there, F5 was not fully integrated with ODL. And so in the beginning, when we started this collaboration with F5, one of the intents was to see what we could do to make it a single point of provision from ODL to provision these roles across the system. So we knew in the beginning we were going to do some customization with the F5 VNFs, and so they provided a RESTful API and bash scripts to allow us to replicate any of the provisioning we were doing from ODL to have a consistent look and feel across the end-to-end system. This has been talked about numerous times already this morning and throughout the industry, or I'll call it the community, is that the OpenStack implementation of SFC does not integrate with ODL. So there's some other demos that have been done here to use Hacker or some other VNF manager to bridge the gap between ODL and OpenStack to provide the naming convention or location of these VNFs to actually do the SFC. So, and there's in the Intel booth, there's a demo of, for example, using OpenO to bridge the gap between OpenStack and ODL for that. So top 5 takeaways. I listed the patches that we've upstreamed from this engagement. So if you're curious specifically what patches we've upstreamed, those are listed there. And what releases they'll be targeted to land in or fixed in. Number one, I want to highlight, and this is an ODL conference, but we were taking a more of a solution perspective, right? We wanted to take all the existing open source ingredients, working with a commercial VNF that is typically found in the Gi-LAN, so F5 commercial VNF. We wanted to NSH enable that VNF. We wanted to see what gaps existed from open source components to actually realize an end-to-end solution. So Intel takes a comprehensive approach to pull together all these different components from ODL, OBS, FIDO, and OpenStack. And there are some interoperability issues that we've highlighted here, but there is definitely momentum that is getting resolved. We definitely confirmed that the F5 VNFs supported NSH-based service function chaining, and this is, we believe, as an industry, there's market data supported that the Gi-LAN is right for this technology. Currently, there's a bunch of proprietary, call it trombone type network configurations in Gi-LAN, not very efficient. Number 4, what I mentioned earlier is that Intel is working with Nano and open communities to address the gap between provisioning between ODL and OpenStack to allow the service function chain to scale more easily. Also in this engagement, F5 has got more in tune with some of the Intel technologies like PPK and some acceleration technologies. They're evaluating incorporating those into their roadmap. And then, like the last one there is that what we wanted to demonstrate here was that this technology can be used for VNFs that are seen in Gi-LAN, but those VNFs can also be used in other enterprise segments. So call to action. I highlighted a package that we're upstreaming. I encourage you guys to take a look at that and provide your feedback. For other commercial VNFs, you can look at the documentation we're providing along with F5 to replicate or to follow on some of the work we've done with NSH-aware VNFs. We are posting a solution implementation guide that's very detailed on all the steps we've done and Tarek went through very quickly. I encourage you to take a look at that, provide feedback. The intent of that solution implementation guide is to provide transparent learnings and feedback to exactly what we've done. If there's any questions, concerns, or more questions, you can follow up with us. And there'll be additional white papers beyond the solution implementation doc that we'll be posting at network builders and other sites that will be available for under consumption. From F5, Randall, do you want to?
Yeah, so a couple of things that we saw when we were trying to go through this, especially with ODL, was the ability to edit the service function path IDs. They were automatically generated, and we had to go back through and change a whole bunch of other things every time we generated those. So there would be ability to revise those. It'd be great. The other one is enabling more generic implementation of VNFs, because not all VNFs fit into a firewall, a DPI, or something else. There's a large range of VNFs out there. And then F5 is going to continue to take a look at this with new technology, implement it with a newer Boron release.
So we try to do this quickly, about 25 minutes, but for other sections, we suggest you attend if you're interested in this topic. They're listed here. In the demo booth, the info demo booth, will have this. The demo Tarek will be available down there as well, so if you want to have any follow-up conversations or questions on exactly what we're doing, engage with you there. So at this point, I think that's about time, but if there's any questions, anybody wants to bring up any comments?
Integrating this solution with what PGP is now specifying for SDI-LAN?
Yeah, so originally, and I didn't go through this, originally that first slide, right, to go back, what we were looking at is integrating with 3GPP PCRF policy, right? So if you go back, let's do it in the slide. Yeah, so originally we could draw a dotted line from ODL to PCRF. We were evaluating how we could leverage the SD interface and kind of bridge the policy of a comprehensive 3GPP and SDN policy. We just didn't get there, honestly. We were focused on functionality of that right-hand piece. As Randy alluded to, the next step would be incorporating 3GPP policy for having consistent policy from both the mobile core to the PCI.
I want to call out an important point since we're already on this slide. The RESTful API was the way we circumvented the issue that Randy just mentioned about the path IDs changing as you deploy them, or you get an automatically generated path ID, to put it more accurately. So we use the RESTful API so that we can update the F5 classifier with rules on the fly, so I can add a new rule, remove a rule, reset the rule, list the rule, and see which, just update the classifier with different mappings between source IP and path to be taken, especially because the path ID was changing dynamically or on the fly.
Any other questions?
Again, we'll be at the Intel booth downstairs. I'll be more than happy to give you a one-on-one demo, slower. We did have a very limited time, but there was a lot to show here, and I can show you a more in-depth live version as well.
Okay, thanks.
Thank you.